Okay, so today we're going to talk about divisibility rules. Divisibility rules are numbers that are divided evenly. So divisible means a number that can be divided evenly and will have no remainder. Okay, this is going to help us when we get to our prime and composite numbers, which we will talk about in a little while. Okay, so the rule for 2. The rule for 2 says that if the number is even, okay, if it's even, it will be divisible by 2. So our even numbers are 0, 2, 4, 6, or 8. So if the number ends in one of those numbers, it's divisible by 2. For example, the number 118, it ends in an 8. So 118 is divisible by 2 because it ends in an even number. Okay, so any number that ends in an even number can be divided evenly by 2. Okay, the next one is the rule for 3. The rule for 3 is a little different. It says if the sum, which means add, of the digits is divisible by 3, then the number is divisible by 3. So I did a couple examples. For the first one, 45. 4 plus 5 equals 9. So that means 45 is divisible by 3. So you can say 45 divided by 3, and you get a whole number with no remainder. Okay, the other one I did was 336. 3 plus 3 plus 6. So I added all of these digits together, and I got 12. 3 goes into 12 evenly. So since 3 goes into 12 evenly, 336 is divisible by 3 with no remainder. Okay, the next rule is the rule for 5. If the last digit ends in a 5 or a 0, then the number is going to be divisible by 5. So for example, the number 455, it ends in a 5. So if I take it and I divide 455 divided by 5, 9 times 5 is 45. 45 minus 45 is 0. Bring down the 5. 1 times 5 is 5. Subtract, and I get 0. No remainder. So my answer is just 91. Okay? So anything that ends in a 5 or a 0 is divisible by 5. Now, those that end in 0 are also divisible by 2. They can be divisible by more than one number at a time. The last rule is the rule for 9. The rule for 9 is exactly like the rule for 3, except for it's divisible by 9. So if the sum, which means add, of the digits is divisible by 9, then the number is divisible by 9. So the first example I did in yellow says 27. So 2 plus 7 equals 9. So 27 is divisible by 9, because we know 9 times 3 is 27. Okay, then I have 756 divided by 9. 7 plus 5 plus 6 equals 18. 9 goes into 18 evenly, so 756 is going to be divisible by 9. Okay, so let's work that problem out. If I take 756 divided by 9, if I take 9 cannot go into 7 evenly. So we have to look, can it go into 75? So we have to say 75 divided by 9. So I know 8 goes into 75. Okay, so 8 times 9 is 72. Because that's as close as I can get without going over. 5 minus 2 is 3. Bring down the 6. Okay, and then we have to say 36 divided by 9. So we're looking at 9 times what equals 36, which would be 4. 36 minus 36 is 0. So that means the answer is 84. No remainder. So 756 divided by 9 has no remainder. Okay? All right, some vocabulary. Factors. A factor is a whole number that is multiplied with another number. So 54, or 5 and 4 are factors. 5 times 4 equals 20. The factors for 20 are 5 and 4. What we do is we make T-charts to find all the factors, because when we're looking for factors, we have to list all of them, not just a couple of them. And this is going to help us when we get into fractions. So this is super important. Factors for 10. So we make a T-chart of factors. So here's my 10 and here's my T-chart. So we're going to list all the factors that equal 10. I know 1 times 10 equals 10. 2 times 5 equals 10. 3 doesn't go into 3 times a number doesn't equal 10. 4 times a number doesn't equal 10. But 5 times the number equals 10, and that's already here. So there are my factors. 1, 2, 5, and 10. Okay, so the factors are the numbers multiplied together to equal a number. Okay, prime and composite numbers now. Let's look at composite first. Composite is a whole number greater than 1 that has more than 2 factors. Okay, so when we think of composite, we think of composite as loving company. So composite numbers, love, composite equals company. Composite numbers love company. That means they have more than 2 factors. They want as many friends over as they can. So if I'm going to look at a number, say 18, I'm going to do a T-chart for the number 18 and see how many factors it has. 1 times 18, 2 times 9. 3 goes into 18 6 times. 4 doesn't go into 18 because evenly. 5 doesn't go into 18, and then 6 does. So there's all my factors. 18's factors are 1, 2, 3, 6, 9, and 18. So 18 has 6 factors. Okay? So a composite number is a number greater than 1 that has more than 2 factors. So 18 has 6 factors, so that makes it a composite number. Then we have prime. Okay, prime is a whole number greater than 1 that has exactly 2 factors, 1 and itself. So when we talk about prime, we look at this. Prime is all about me. Okay, we call prime selfish because all it ever sees is I and me. Okay, so 2 factors, 1 in itself. So if I have the number 11, the only way to make 11 is 1 times 11. 2 factors, 1 and 11. The number 7, 1 times 7. The number 31, 1 times 31. Those are all prime numbers because they only have 2 factors, 1 and itself. And when I say itself, I'm saying 31, so the factors for 31 are 1 and itself. Okay, does that make sense? Okay, so prime numbers, all about me. Only 2 factors, 1 in itself. Composite numbers, loves company. More than 2 factors. Okay? So we're going to use this prime and composite information plus our divisibility rules to complete a hundreds chart of our prime and composite numbers.